Let's quickly discuss utility shader in this lesson. Utility shader is a very general shader that can be used for creating passes for use within compositing packages. It can be used for debugging problematic areas and so many other things. So let's first of all create a utility shader. So Material Manager, create Arnold, surface, and utility. And apply it to the sphere, to the abstract 3D object, and to the clock here. And let's run the IPR and open up our shader. We have shade mode, which specifies how the surface should be shaded. We have a few shading modes. We have n.I, which shades the surface based on its normal and the incidence angle. We have Lambert, which uses the default Lambert shader to shade the surface. Flat mode uses single luminous color. We have ambient occlusion and plastic mode, and plastic mode has both diffuse and specular components, and metal, which has only the specular component. We use shade mode just to specify how we want the surface to be shaded. The main attribute in the utility shader is the color mode, which allows you to use different modes like UV coordinates, normals, object IDs, and so on. So I can change the color mode, for example, to normal. Now we can see surface normals in the scene. And now using the shade mode, I can change how the surface is shaded, but we still see the surface normals in these different shading modes. For the majority of times, you use utility shader to output different passes like normals to use inside your compositing app. In that case, the best shading mode would be flat. So let's change the shade mode to flat and take a quick look at some of the different color modes or shade modes that we have. You have color. You can use a simple color, and the color can be defined down here. You have geometric normals, which is the shader normal in world space. Unbumped normal is smooth unbumped normals in screen space. You have normals, which is the normal in world coordinates. We have barycentric coordinates, which is the barycentric coordinates of the primitives. You have UV coordinates, and right now our abstract object has no UV, as you can see from the tags list, and that's why it appears black. Let me just quickly apply this grid shader to this object, right click on the tag and choose generate UVW coordinates. And now if I delete this shader again, we can see the UVW coordinates of this object as well. Let me open up the utility shader again. We have U coordinates, V coordinates. You have there is a surface derivative based on U and V coordinates. We have shading point relative to bounding box. We have primitive ID, which shows each poly or face with a different color in a triangulated mode. We have uniform ID, which shows each poly or face with a different color in a quad mode. We have triangle wire, which renders a triangulated wireframe. Polygon wire renders a polygonal wireframe. As quads, you have objects, which based on the name of the geometries assign a color to them. Edge length shows the edge length of the objects as a heat map, and you can detect over tessellated areas using it. We have float grid, which maps a color around the hash function based on the shading point. We have reflective lines that can be used to specify the contour line of the object. We have bad UVs, which shows the object with bad UVs in magenta. So if I just delete one of these UVW tags, you can see it becomes magenta, and that means it has a bad UV. We have number of lights, which is the relative number of lights at the shading point. We have object ID, which assigns different colors to objects based on their ID. That can be very useful in compositing because you can have different mats for different objects. Let's say I want to my clock and my sphere to have one common mat, so they should have one color. Let's add an Arnold parameters tag to the clock here, and under tag tab you have user option. You can specify the object ID here. Let's type ID space 1 and control drag the same tag on our sphere. And as you can see from the IPR, because our clock and the sphere has a similar ID, they have a similar color. And finally, we have bump difference and pixel error as well. So I invite you to go and read about these different color modes in the Arnold Sport website, but in the future lessons we are going to be using the utility shader practically a few times and show how to render out different color modes as passes to be used in compositing. We have overlay mode, which allows you to overlay a wire or a wireframe on top of your shade and color modes. We have AO distance, which controls the maximum occlusion distance that is sampled. So if I use ambient occlusion shading mode and decrease this value, you should be able to see some change in the IPR. And we have this kind of roughness parameter, which is for the metal shading mode. And that would be it in this lesson. We covered utility shader briefly. See you in the next lesson.